All right. Muscles, levers, and pulleys. So the bones, joints, and muscles of the body are sometimes described as working as simple machines, either levers or pulleys. Levers are complex, although simple little machines. They have different parts. They have a lever, which might be a beam, as in a beam of wood, um, or in the body, a bone. Uh, Lever systems have a fulcrum, which is the point at which a lever pivots. Effort must be used to use a lever system. Effort describes the force exerted on the lever. And finally, there is some load that the lever system is trying to move. The load is the object acted on by the lever. Levers are amazing, simple machines that magnify the force applied to them. And here is a picture of a simple lever system. There is the lever, the blue beam, the fulcrum, the green triangle. The effort is shown with an arrow, and the load is shown with a little black like dumbbell or weight kettlebell, I don't know, here. The load, of course, would be under the influence of gravity. So it would be kind of pulling down on the end of the lever here. When effort is made on one side of a lever and the lever system is set up in a certain way, the small effort on the lever will be translated into a large force on a load. And I think that everybody has used some kind of lever at some point in their life. If you've ever used a crowbar to dig a stone out of your garden, um, for example, you've used a lever. The parts of a lever system may be classified by the arrangement of the beam, the effort, the fulcrum, and the load. And you can look at these three different classes of levers and figure out where is the beam, where is the effort, where is the fulcrum, and where is the load in the simple pictures of the lever systems on the left. And then you can look at the examples given of the muscles, joints, and bones in the body moving as lever systems. I think looking at the picture is much more useful than me kind of talking you through it. All right. The most common lever system in the body is the class 3 lever system. It does not give much mechanical advantage and it requires a large effort, but the body uses lever systems the best it can, let's say. So an example given here is of the elbow joint and the bicep brachii. And what we have here is that there is a bit of the bone that is behind the fulcrum of the elbow joint, and the bicep brachii makes the effort of pulling on the bone, actually quite close to the fulcrum. And by doing so, it lifts the bone, which has, weight. So that would be the blue arrow would be the load or the weight of the bones, muscles, structures of the forearm, wrist, and hand. And the action completed is that the bicep brachii performs flexion of the elbow joint. So you can see this, you can think about it and think, well, yeah, I can understand why that is not the most efficient lever system. Doesn't seem to, give much mechanical advantage. And I can imagine that it requires a large effort if I imagine somehow using this little simple lever system myself. There are a few class 1 or class 2 lever systems in the body. The class 1 lever is actually the most effective. And you can go through the class 1 and the class 2 lever systems in detail here. The mechanical pulley is a wheel that changes the direction of a force applied to a rope. Again, this is a remarkable little system. If you look in the left bottom of the picture to the side, it's showing that there's a pole, as in a flag pole. At the bottom of the pole is the flag, the little gray square here, rectangle here. And they're showing that you would attach the flag to the bottom of a rope, and then you would have the rope fed up the flagpole and then around a pulley at the top of the flagpole. And then there would be a rope going down, down, down. And this is the end of the rope that could be grasped by a person who wanted to lift the flag. And the person would pull on the free end of the rope. And by doing so, the force that they are exerting, pulling on the rope downwards towards the ground, is translated by the pulley to a force pulling the flag up, up, up to the top of the flagpole. So that's a mechanical pulley. An anatomical pulley is a bone that changes the direction of a force applied to a tendon. The patella bone acts as an anatomical pulley. It changes the direction of force applied by the quadricep muscle to the tibia. And here there's a picture that's showing you that the force that the quadriceps femoris is exerting is, straight up towards the groin area. But as the force goes over the patella, the force is translated into one that pulls up on the leg. So this is the example that is used. So, okay, that was describing muscles as levers and pulleys. I think that, it's interesting if you're interested in mechanical things, but I will say no more about that. So now